Okay. Alright, today we are going to review methods for solving quadratic functions. Our first method that we learned was graphing. So that's when we look at our graph and we find our x-intercepts. We have one right there. It looks like x equals 1, 2, 3, 4. Yep, x equals 4. And one over here at x equals -2. We can only use this method when we're given a graph. So use when given graph. And then we look for our x-intercepts. So this is a nice method, but only used sometimes. Look for x-intercepts or our roots. Okay, next method we have factoring. So for factoring, we can draw our box and put, oops, that's a bad box. Let's try that box again. Okay. Your box might look better than mine. Put your first term in the top left, last term in the bottom right, and do a little side work. So we need two numbers that add to b, which is -7, and multiply to a times c. A is 1, so 1 times 10 is 10. My two factors are -5 and -2. Does not matter what order you put them in the box. And then now we factor out the GCF. X squared and -2x have an x in common. -5x and 10 have a -5 in common. X squared and -5x have an x in common. And -2x and 10 have a -2. So I come over here and I write my factors. X minus 5 times x minus 2 equals 0. And now I have to use the zero product property and set both of my factors equal to 0. I then solve for x, so I add 5, so I get x equals 5, and add 2 on this side, so x equals 2. So my solutions are 5 and 2. We're going to use solving quadratics by factoring when it's in, let's see how the word is, use when it is easy to factor. So if you're struggling trying to figure out what your factors are, I would not use the quadratic. I would not use factoring unless the directions tell you to. Use when it's easy to factor. Or you might use it, or use when they give you the factors already, when it is in factored form. So if they gave you x minus 5 times x minus 2 equals 0, we would solve by factoring and set each one equal to 0. Biggest part about this is that your equation must be equal to 0. If it's not, then you can't use this method. Or you can get it equal to 0. Equal to 0. Alright, next one. We have our quadratic formula. So, quadratic formula. First thing we have to do is label our A, B, and C. A is 2. B is -5. C is 3. So, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Simplify your discriminant first, what's underneath your radical, and we end up getting the square root of 1. Make my radical too big. All over 4. Now break that up into two different ones. X equals 5 plus 1 over 4, which is 6 over 4, which is 3/2, or 1.5 if you're using a calculator. And 5 minus 1 over 4, which is 4 over 4, which is 1. So my solutions are 3/2 and 1. And let's add over, step over here. I actually took the square root of 1 to be 1. Alright, use quadratic formula when factoring looks difficult. When factoring looks difficult. So if you can't easily find those factors, use quadratic formula. Or use it when a is greater than 1. So if your first term is bigger than 1, use quadratic formula. Or you might use it when you can't factor. So sometimes these equations are not factorable. Use when you can't factor. Alright. Another big thing to remember is that equation must be equal to 0. So if it's not equal to 0, you have to move things to one side. Equation must be equal to 0. Alright, next method we have completing the square. So we are going to complete the square here. So my first step is to add my constant to the other side. So x squared minus 4x plus, I'm going to leave a space, equals 18 plus, leave a space. Now I need to do b divided by 2 squared. My b term is negative 4 divided by 2 squared. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So I am adding 4 to both sides of my equation, because what you do to one side, you must do to the other. Now I have to factor this. I know that because I completed the square, this is going to turn into a perfect square trinomial. So I have x, I use whatever sign is here, so minus, and then the square root of my number over here. Square root of 4 is 2. And on this side I combine, and I have 2 of those, so that's squared. 18 plus 4 is 22. So now I need to square both sides, take the square root. On both sides I get x minus 2 equals plus or minus root 22. And then I add 2. Make sure you stick that 2 in front. X equals 2 plus or minus root 22. Alright, so completing the square. When are we going to use this? Hardly, unless they ask you to solve the quadratic by completing the square, I would not use it. But you do need to be familiar with it, and they might ask you. You want to also use... Sorry, our bells are long. You want to also use when you need to put the equation in vertex form. Use when you need to put the equation in vertex form. That's about the only benefit it is to us. In vertex form. Or if they ask you to solve by completing the square. Alright, our last method is the square root method. And this one's nicer because it's like completing the square, but the work's already done for you. So we have a square, so we square both sides. So I get x minus 2 equals plus or minus root 5. And then I add 2 again. So x equals plus or minus, 2 plus or minus square root of 5. So we are going to use square root method when you have parentheses given to you and an exponent of 2. Parentheses and an exponent of 2. Other than that, I would not use this method. Alright, you now have 4 try this problems. Each of them are specific about which method they want you to use, so give them a try. And if you have listened to this all the way through, please draw a smiley face on the bottom of your try this page.